Okay, so let's start with like some logistics first while people are joining us. So first of all, welcome everyone, and thank you for joining us today for this OpenTelemetry session. I'm Eran Grabiner from Specto, CEO of Specto. With me, our speaker today, the OpenTelemetry expert, the one and only Michael Haberman. As you've probably seen, this session today is going to be about some production aspects of OpenTelemetry, which is how to deploy the actual collector and how to get it to work with your Kubernetes environment. This is part of a wider series that we're doing around OpenTelemetry, starting from the OpenTelemetry Bootcamp that you can find online, and we will also share in the chat in a second, which is like a wide series of how to get started with OpenTelemetry. After that, we started to doing all these types of sessions about specific topics of OpenTelemetry based on what people are actually asking us and looking for. So we hope you will find this session relevant and interesting. As always, this is like an open session, so feel free to reach out over the chat with questions. We will try to facilitate it as Michael is going through his presentation, but we'll try to address everything. Also, something new that we are trying this session, we're going to have a short poll about your OpenTelemetry usage, just to trying to figure out what is the level of the different folks that are joining these sessions. So in a second, we will launch like a 4 questions poll. Feel free to answer it throughout the session. No commitment or anything, just trying to figure out the different levels of folks. Yeah, and I think that's it. We will kick it off. Go ahead, Michael.
Okay, great. Sounds awesome. So hello, everybody. My name is Michael, and today we're going to speak about the OpenTelemetry Collector and to be able to run it on Kubernetes. So just a quick introduction about myself. I've been working with microservices and distributed application for 5-6 years now. Did a lot of cool and interesting projects in this area, and in the past 2 years, mostly around Specto, I've been investing my time with OpenTelemetry and gained an experience with helping customers deploying it, managing it, troubleshoot it, and we're trying to capture this data, capture this experience, and bring it to this session. So, what is our goal for this session? Our goal, or first goal, is to kind of have a basic understanding, making sure that all of us are aligned on the goals of OpenTelemetry, what it is doing, how it is doing so. We won't put too much time into it. I'm guessing that some of you are getting started and some of you are more experienced, so just like to set the stage. And then we're going to deep dive into the OpenTelemetry Collector and how to deploy it in Kubernetes using a Helm chart and the OpenTelemetry operator. So by the end of this session, you know what OpenTelemetry is, you understand why the collector is so important, and how to be able to deploy it in Kubernetes. Okay, so let's get started. So why we are speaking about OpenTelemetry and Kubernetes altogether, why we chose to have those 2 sessions, those 2 topics together. So the first and obvious reason is that OpenTelemetry is an application that you need to run, and it needs to be, it usually run in Kubernetes environment or container environment. But there is also a very important reason, because the companies and other D teams that are using Kubernetes also need OpenTelemetry. So most organizations you would see that running a Kubernetes environment, they are using some kind of a distributed application architecture, whether microservices or some other approach. But in this environment, the distributed environment, you usually find the need for OpenTelemetry. So it's not only that it makes sense from infrastructure, but it also makes sense from the usage and the actual use case that you're getting from OpenTelemetry. So if we're trying to capture what is OpenTelemetry, and I think it's it's very important that we really understand what it is OpenTelemetry, why we want to deploy it in Kubernetes. So the first thing, it's an open source project. It's under the umbrella of the CNCF, the Cloud Native Computing Foundation. The Cloud Native Computing Foundation is a wide project that's responsible on a lot of cool and interesting projects: Kubernetes, OpenTelemetry, Prometheus, FluentD, tons of interesting projects. So OpenTelemetry is one of them, and it's actually the second most active project in CNCF, second to Kubernetes, to be honest. So what it is, OpenTelemetry, at the very core, it's a specification. It's not an implementation, it's just some documentation, some protocol defining how to collect telemetry data. When I'm saying telemetry data, I mean any type of data that we collect from the application in order to understand how the operation is operating, whether it's operating in a good way or a bad way, or what's going on. So OpenTelemetry, at its very core, it's a simple specification how traces, how logs, how metrics, and other types of telemetry data should be collected and should be sent to a destination. This is creating a very important piece of OpenTelemetry because it's becoming this vendor agnostic way to define how we should monitor our application, how the data should look like. And everybody is aligning on that. The big vendor players, the small startups, the cloud provider, everybody is aligning to the OpenTelemetry specification. So now we have a specification, bunch of README documents in GitHub. Now they need to come into life. And this is done by really implementing. So the way that OpenTelemetry is collecting the telemetry data is by implementing an SDK, a package, a library within our code, within our application code. And this application code starts to collect data and start to understand what's happening in our services. So for each programming language, you would find an implementation of the OpenTelemetry SDK. So probably not to every programming language, but there is like 11 or 12 of the most common ones. So now the implementation part is collecting the data and it can export the data, but we need to have a backend to ingest it. So we have a backend that can ingest the data and then send it, process it, and send it to however we configure it. This backend, that's the OpenTelemetry Collector. So it's a big piece because all the data that is going to be produced by the OpenTelemetry SDK is going to be consumed by the OpenTelemetry Collector. So when I'm saying telemetry data, let's be a bit more specific. Currently, OpenTelemetry supports 3 types of telemetry data: logs, metrics, and traces. I'm assuming that you're all familiar with logs and metrics, so I won't spend a lot of time on it. I'm not sure everybody knows distributed tracing, so I may allocate a bit more time to discuss that. So logs, that's the application story, right? When we run the application, we write code that kind of output the story of what happened, and we probably all know and work with that. And we have the metrics; those are numbers that are telling us if our application is performing the way that we want, or if we are exceeding a specific number, we probably will trigger an alert. Traces, they're also telling us what's happening in the system, but it's doing it with a context. They're not only telling us what happened, they're also telling us why it happened. And we will see that in a second. Just before I'm jumping to deep dive into traces a bit more, there are more telemetry data that OpenTelemetry is going to support. The first of them would be code profiling. So with a single SDK, you will get logs, metric, traces, and code profiling, and of course, more to come. So let's take a look at a trace. In front of you, you can see a visualization of a trace. This is Jaeger UI. Jaeger is probably the most common open source tool to display traces. So let's look at this trace. If you look at the left side of this UI, you can see a tree view. It's important that it is a tree view. Just remember that in order to have a tree view, you need to have a parent-child relation. And you can see here that the order service got an API call to purchase order. That caused the order service to send an API call to the user service, to the /user/verify endpoint. Only after that, the order service sent an API call to the stock service, to the update stock, and that triggered a DB call, and we had here 2 additional DB calls. You may argue and say that each line in this table is kind of a log, right? It's an event telling us that something happened. And that's almost correct, but you're missing 2 important pieces. The first one is that I know that this DB query, this stock items.find, it happened because the stock service got an API call to /update, and that happened because the order service got an API call to /purchase. So I understand the context. I understand that each individual call, what additional actions it caused. So I understand what happened and also why it happened. The second part here, this is more for kind of a performance view that we can understand. So you can see here how long the entire operation took. Now, you can see that it started at a given time and it spanned over time. This is why in OpenTelemetry, we're not referring to individual events as events, we refer them as spans because they span over time. So you can see here that the user service ended and only then the order service communicated with the stock service. So you can also understand not only how long it took, but also if things happen in parallel or in sequence, which in some cases could be very, very beneficial when you're trying to debug performance issues. So this is how traces looks like. And this is the benefit that you're getting from traces. So we established that you need to implement OpenTelemetry and SDK within your code. And it does this beautiful magic you can see right here. And we said that we need to have a parent-child relation between the different spans. So how's that work? You need to have some mechanism in place in order for that to work. So let's give it a quick look. So in front of you, you can see that service A is communicating with service B and then a database. You can also see that service A and service B already have OpenTelemetry installed in it. We already deployed the OpenTelemetry Collector, again, the backend that is going to ingest the data. And now we want to understand how the tracing data look like. So when service A is going to send an API call to service B, we expect to get at least 2 spans. The first span will be service A saying, hey, I sent an API call to service B. And the second span would be service B saying, hey, I got an API call from service A. In order to do that, service A has to tell service B 2 things. First, we are on the same trace ID. And second of all, service B needs to point to the parent, and that's service A. So when service A is sending an API call, it's going to look like that. It's going to look, hey, I'm sending out a span that represents this call, the API call to service B. This is trace ID number 1, span ID 55. Again, some random IDs. And this is the root. We have no parent. This data is going to be injected to the call to service B. This is an HTTP call that we see in front of us. And in most way that you communicate between services, you have a dedicated place to send the data and a dedicated place to send the metadata. With HTTP, that's the headers. This is where you can inject metadata. So OpenTelemetry injects the OpenTelemetry context. That would be the span ID, that would be the trace ID, and down the road we'll speak about sampling, so also some data about sampling. So when service B gets the call and produce the span going to look like that. It's going to say, hey, I got an API call. This is trace ID number 1, because we're still on the same trace ID. A new span ID, that will be 66, and I am not the root, I have a parent, I got it from the context, and the parent is 55. The same would be for internal actions that happening within service B. So service B will report, hey, I made some DB query, same trace ID, my parent is 66 and I'm span ID 77. So that's what causing OpenTelemetry to be able to draw traces or have a data structure that represents traces. So now that we are totally experts on OpenTelemetry SDK and we understand how it works, let's take a quick look how a full deployment of OpenTelemetry would look in terms of the different components that we're going to have. In some sense, when you're thinking on open sources, you usually think on something that you import to your code, you initialize, and it works. OpenTelemetry, it's an open source, but it's kind of a full stack open source. It has its own kind of front end that the OpenTelemetry SDK that collecting the data, and it has a backend. So the first layer, that's your services, that's your application. So you have service A, B, and C, and you implement the OpenTelemetry SDK. Cool. Now we have the backend layer. The backend layer is going to get the data from the OpenTelemetry SDK into the OpenTelemetry Collector, and then do something with it. It may vary between different configuration. For example, you can write it to Elastic, and then Jaeger can look at the Elastic, and you have your full stack solution where the data is persistent in the database, and some visualization tool is looking at the database, or you may not want to manage that and you want to send it to a vendor. That works as well. So this is the OpenTelemetry stack. This is everything that you need to have in order to have OpenTelemetry running. Okay, now I want to have a deeper look into the OpenTelemetry Collector. The collector, you may argue, that's the most important component in your architecture. Implementing the SDK, it's fairly simple. It could be a bit more complex, but usually it's fairly simple. And the OpenTelemetry Collector is going to ingest all the data, process it, and then do whatever it needs to do with that. And you need to make sure that that's running and working under the load that that your application produce. Otherwise, you don't have any telemetry data. So it's responsible mainly on three things. The first one is to receive the telemetry data. I need to get it, and then I need to process it. We'll see in a second what do I mean by I say to process it, and then I need to export it. I can export it to a database, to a vendor, to whatever, but it needs to be sent to some place. So let's go on each one of those responsibilities with a bit more details to understand how it works. Okay, so the first thing that OpenTelemetry does, the OpenTelemetry Collector is doing, is to get the data. And the OpenTelemetry way to get data, to send and to get data, that's the OTLP, the OpenTelemetry protocol. That is a protocol that is designed by the OpenTelemetry project, and by default, all OpenTelemetry component will produce and get this data. It could be sent either over HTTP or over gRPC. And this is mostly a networking configuration of the protocol. And then things like which port it's listening to, SSLs, and things of that sort. There are other types of data that the OpenTelemetry Collector can receive, such as older versions of distributed tracing like OpenCensus and Jaeger and Zipkin and those kind of things. So you have more of those if you need it. Usually you would be good with the OpenTelemetry protocol, the OTLP. Now we need to talk about processors. When we ingested the data, we are kind of defining that a receiver got the data, and then it's sending it to a kind of a data pipeline process within the collector. This data pipeline is allowing you to alter the data. Maybe you want to change things. Maybe you want to add some keys, remove some keys. Let's say that you got some sensitive data that you want to exclude. Let's say that you want to add an additional field, like I want to say to which Kubernetes node we ingested it. Maybe I want to improve some performance. I want to have a memory limit so the OpenTelemetry Collector won't exceed its memory. Maybe I want to batch the processing mechanism in order to be more efficient. And maybe I just want to sample the data. We would see it later in this talk that OpenTelemetry generates a lot of data, and maybe I just don't want to persist everything and I want to sample it. So this is kind of a data pipeline mechanism that is allowing you to kind of change the data and control it, usually from performance I don't know, tip for you. So different processors are having configuration, and one of the configuration that they need to declare is whether they are mutating the data. So if you are using a processor that is going to mutate the data, and you have more than one, that is going to cause the collector to clone the data. So you may find yourself taking your entire traffic and just cloning it into two different pipelines. So that could be very expensive, and expensive from a resources perspective, of course. So this is a place that you need to make sure. If you look at the processor definition, you can just see this mutates data, whether it's true or false, and take a look at that. And another important tip, the order that you specify the processor is going to affect the outcome of what is going to be exported. So once this data pipeline is complete, all the different changes, buffering, the memory limits that we had, all of them are done. The spans or metrics or logs comes through the other side, and then they are being exported. When I'm saying exported, so there are several types of exporters that you can find. You can find, again, the OTLP way to export data. This is usually done when you're sending OTLP data from one collector to another. This is something that we would see later in this talk, that in some cases, you're communicating from one collector to another. Again, gRPC or HTTP, however you prefer. Some vendors have their own exporters. That is the case that you are exporting your data to a vendor. You can export the data directly to some open source visualization tool like Jaeger or Zipkin. You can write it directly to a database, Elastic, MySQL, Cassandra. There is a bunch of them out there that you can use. And this is making the collector to directly write the data to a database. And I wouldn't suggest doing that. I wouldn't suggest writing directly from the collector to a database. This is because scaling the collector is super easy, right? You just auto scale. If talking about Kubernetes, just define some HPA, and it scales to really significantly. Whereas scaling your database, that's way more complex. And you can find yourself in a way that you're just writing to the database too much. This is why you would usually have a message broker. So you can write into some message brokers such Kafka, Kinesis, if you're using AWS, that's what we are using. So you writing the data to a message broker, and then you can pull from that message broker in the rate that the database is going to be able to work with this load. So this is kind of the end station of the collector. We got the data, we process it, and now we're sending it to some external resource, and hopefully to reach the final destination.
Michael, a few questions here before we're moving forward. like double clicking on the exporter. Two questions. First of all, how can you influence it? Like, is it only through the configuration? How can you make extensions by yourself? And lastly, is it like one exporter for each signal, metrics, logs, traces, or we have one for all? If you can elaborate on that as well.
Yeah, sure. We will see in a second an example of how it looks, but just to answer it really shortly. So the definition of exporter is done through a configuration, a YAML configuration. You can write your own exporter if needed, but usually you just configure the default ones. And you need to define different pipeline for different telemetry data. For instance, if you're writing traces to MySQL, you probably want to write the traces to MySQL. You probably want to write the metrics to Prometheus. So it makes sense to have different exporter to different telemetry types. Okay, so exactly talking about that. So after you define exporters, receivers, and processors, you need to define a service. A service is the definition that wraps it all together. Service is defining two main things: the extensions that we will see in a second. Extension, those are things that the OpenTelemetry Collector offers that are not part of the ingestion and exporting pipeline. There are other stuff like health check. We want to make sure that the service is up, the OpenTelemetry Collector is up, or reporting metrics of the collector in order to debug it. And the pipeline itself, you have different pipeline for traces, logs, and metrics. So let's take a look on how it looks. So you know what? Let me jump into some code. Everything looks better when you see it in a VS Code. So let's take a look at the bottom first. So let me increase it even more. So you can see here a service, and in this service, we are defining three types of extensions. We would look into them in a second, and we're defining two different pipelines, one for traces and one for metrics. In this case, you can see that the traces is getting the data through OTLP, is doing batching resource. We will see in a second what is that. We are logging the data, and then we export it to Jaeger. And for our metric pipeline, I'm still using the OTLP. I'm just batching the data, logging it, and sending it to Prometheus. I didn't do like a log section, but you can do that as well. So this is how you define the service and the pipeline. And if you remember, we said that the order is significant. So remember that, that's where the order is coming to significance. So looking at our receivers. So our receiver is defining an OTLP receiver. And I am using the two protocols, not only one of them, I'm using both HTTP and gRPC. And that is all you need to do in order to define an OTLP. You can also define the TLS certificate if you need to. In the processor sections, I did two things. First one is I am batching the data for 1 second before moving on. That is making that the exporter part gets a larger chunk of data to process, to export. That is making it just more efficient. And in the resource part, I am adding an attribute that the key is test.key and the value is gateway, just to see that it works. So that's how we are doing the processing. And in terms of exporters, we have 3 exporters. I am exporting to Prometheus. So Prometheus is actually scraping the collector, and I am exposing an endpoint to scrape the data to Prometheus. And I can have some labels and some namespace. So that's the Prometheus definition. I am logging at an info level. That's the logging. And I am exporting to Jaeger. Insecure because it's a demo. In production, always use secure. And that's the endpoint. So this is what you need to do in order to configure the OpenTelemetry Collector, this is a kind of a simple, straightforward configuration that can get a bit out of hand if you're doing like a full fancy deployment. Okay, so oh, I didn't touch that part. Just about the extensions. So there is of course the health check, just making sure that the collector is up and running, and we have one for performance and one for debugging. So just know there are some other stuff. Those are usually not that critical in terms of the deployment.
Michael, maybe a quick questions about the collector before we move forward. First of all, if you can address like in what situations will I change few collectors one after the other? Why should I even do something like that?
Yeah, so this is a great question. It's such a great question that we'll need to wait a few slides in order to answer it.
yeah, we will get that. And regarding and this is also something that eventually might be done in the collector. But regarding the different signals, how separate those from one another? Meaning, can I move data from one stream to another, from taking something from the tracing data into the logging stream, or those are like complete separate pipelines that I can actually correlate between the data and so on only at the end station?
So those are different pipelines. You can correlate between them in two and a half places. So the OpenTelemetry SDK is producing the data, and it very well can attach one another. So logs can point to traces, traces can contain logs, metrics can contain examples to traces, but it's done in the SDK part. When the collector ingests it, it's mostly separated, separate pipelines that you can't correlate between them. And lastly, if the database stores all of them all together, in some cases you can correlate it back. I will say that OpenTelemetry is maturing at this part, and I think we will see more features down the road.
Cool, thank you.
Okay, so now we're not only expert with the OpenTelemetry SDK, now we are also expert in the OpenTelemetry Collector, and now it's time to really deploy it. And to deploy it, I want us to meet the OpenTelemetry Collector Helm chart. So OpenTelemetry itself, the OpenTelemetry community, the project, is maintaining a chart for deployment on Kubernetes. That means that a lot of the heavy lifting, a lot of the problems, a lot of the hard thing that you need to define is going to be predefined for you. I think that if you're going this route to run the OpenTelemetry Collector on Kubernetes, this is probably your go-to tool. You can, of course, not use it. You can do it yourself, but you're going to find a lot of difficulties that are already solved. And when we're talking about the Helm chart, the Helm chart actually offers two main things. The first one is offering the collector deployment itself, all the different configuration of the application, the different deployment types, as we said, that we will touch, that is managed by the Helm chart. But not only that, it also can help you auto-instrument applications in a very cool way. And we will touch that in of course, down the road. So let's start with saying what the chart is going to define for us. What are the main components that we're going to get out of the chart? The first one is different deployment type. So different deployment types are very important. We will see all of them with a lot of details. So just keep in mind that it's doing that. Let's dive to other bullet points and then go back to it. We have a predefined configuration for traces, metrics, and log. Of course, it's very configurable. You can turn off or on each one of them and define them in different ways. Eventually, this is a config map thing that you're running based on the configuration that I showed you. And configuring the OpenTelemetry Collector, it's not a one-time thing effort. It's changing, it's live, it's something that you, as you move to production, you understand you need to tweak this configuration, and now you want to have the metrics exported to another place. So you're changing it all the time. So it's a very good and easy way to configure it. Then we have the self-monitoring. So the OpenTelemetry Collector produces logs and metrics. It may be funny that the OpenTelemetry Collector itself is not producing traces, but that's the way it is. So all the different things that is telling what the OpenTelemetry is doing, how much traces it got, how much it failed, all those things that is going to tell you how it's performing. Having it monitoring on the OpenTelemetry Collector is very important. It's something that you can find yourself struggling with, trying to understand what's happening when things are not working. So it's going to produce all the data for you. Service account, so you'll be able to access all the secret data that you're looking for. Service cluster roles, so you'll have access to the APIs that you need. HPA to make sure that you can auto scale your OpenTelemetry Collector. Remember that the scale that you are getting from the application. So if you have, let's say, 10,000 requests per second to your services, that means that the OpenTelemetry Collector is going to get more than that, right? Because for every API call that you are getting, there is one spend made, but then you are querying the database, there's an additional spend. So the load on the collector is very significant. So having auto scaling in place, that's important. It is a service by default working with a cluster IP, and of course it allows you to define an ingress in case you need one. Maybe you are only working internally. So those are the core components of the chart. And now, as promised a few times, let's talk about the different modes. So we have 4 different modes. When I'm saying a mode, that means that when we are deploying a certain part of the collector, we're using this mode. You can use few modes altogether. It's not that you have to use only one. So we have a slide for each one of them, but just so we will list them and keep in mind, we have the one that's called deployment or a gateway. That's a standalone deployment. We have the daemon set. That means that each node in the cluster gets in its own collector pod. We have a stateful, that is a static amount of collector with static names. And you have the sidecar, which mean each pod gets its own collector agent. So let's look and figure out what each one of them means. So the deployment mode, which arguably that's the simplest, easiest deployment that you can work with. That means that if your cluster consists of 3 different nodes and you're spinning up the deployment mode and you have only one replica, only one node is going to get the OpenTelemetry Collector, meaning different application pod will need to communicate through different nodes. And that is making it, like a very simple deployment. If your scale is not significant, that's not an issue at all. We have customers deploying that way with low, medium deployment, and it works just fine. Daemon set means that you have a collector for each node, or even multiple replica for each node, that is allowing you to stay within the same node and to not have cross communication between different servers. And it's not making your life more complex. It's a very minor change in the chart itself. In fact, let's take a look at how it looks in the chart to configure each one of them. because it's really almost too simple to configure. So I'm in the repo of the chart, and you can see here that we have a daemon set only, right? So I have a daemon set only, and you can see here that to run the daemon set, all you need to do is just to have the mode daemon set. Now, this is a working, functioning OpenTelemetry collector. To spin it up, all you need to do, is to have Helm installed, and then it's up and running. We will do it in live if time permits. So that's defining the daemon set, and that is defining the deployment. Here we define it with a bit more details. We have the mode, we have 3 applicas, and we set some resource limit. In case that you want to have both deployment, so here you have the deployment and with some limit. So we have the deployment and we have the daemon set, and the daemon set is actually containing the different configuration of the different pipelines, the logs, metrics, and traces, and then exporting it to some external place.
Like each collector as daemon will have its own database for like the different signals, or will use one database for some?
So in terms of databases, again, each individual collector is going to send it to a database. I don't see much value in separating the database because then you have different telemetry, different part of a single transaction within your service separated throughout different databases. So usually you would use one single database. It could be different database for different telemetries, like metrics in Prometheus and logs and Elastic, but I would use a single database. Okay, then the third option, it's stateful set. This means you have a fixed amount of OpenTelemetry collectors running with static names. If, let's say, the OpenTelemetry collector number 2 is crashing, then we spin up one with the same name. I'm not aware of a use case that I would use it because I can always use like load balancer, and I don't really care about the name of the collector, but it is a possibility to do that. In the documentation itself, the reasoning for that is to have a predictable names, which is great. If somebody needs it, you have this option. And the last one is sidecars. So sidecars allow you to have, for each pod, to have a dedicated OpenTelemetry agent, and that agent would communicate with a daemon set or deployment to the OpenTelemetry collector. The reasoning to do that is that the OpenTelemetry collector, the SDK itself, need to send a lot of data. Sending the data from the application to a remote server, to a remote collector, that could affect the performance of the application. And having a sidecars allow you to send the data to the agent with much less performance impact. And then the OpenTelemetry agent, it would get the performance impact of sending the traces, logs, and metrics to the OpenTelemetry collector. I would say this is the most complex and most comprehensive solution that you can go with. I would also say that most applications out there don't need this complexity. It may sound really good and really fancy, but in real life, spinning up the OpenTelemetry agent, managing the sidecar is kind of a headache, and you don't really have to unless you're a very, very intensive application.
That's maybe a good point to touch a little bit the subject that we also wrote something about. I'll send it later on. But what if we have a service mesh in place? If we already have Istio running, we just had a question about that.
So Istio doesn't interfere in any of that. It's an additional sidecar. By the way, if you think about the Istio architecture, it's very similar to what we see here, right? We have the Istio sidecar and we have the daemon, very much similar to what we see here. So it doesn't interfere in any way. Istio and service message in general knows to produce telemetry data by themselves. They also know to produce spans and traces. So they can be part of your observability stack. They can send the telemetry data that they are creating to the OpenTelemetry Collector. With logs and metrics, that's easy to configure. With traces, it's actually a bit more complex, but you can get it done. We also have some content around that if you're interested. Okay, so now that we understand the different deployment, maybe just a summary before we are jumping to other topics. 100% I would start simple, right? Unless you're doing your first deployment to a very significant high load performance environment, start simple. Make sure you understand the different components, the configuration, you set up the monitoring, you saw the HPA, it's working, everything is working in your staging environment, and it's like very, very simple. Great, get the confidence. Now start to think on more complex architecture. And I wouldn't run to have like a deployment with a daemon set, getting data from a sidecar, just that's very complex, and I wouldn't start with that. A bit about autoscaling, if you are starting to speak about the complexity of production. By default, the autoscaling that the chart is doing is using CPU. CPU, it's working. I would say it's working even quite well if you don't have peaks in your traffic. If you're having more peaks in your traffic and your traffic is not kind of stable, I would try to base the autoscaling based on traffic. So I would come up with a metric to requests per second, per minute, and then define how much how much each collector can ingest in terms of requests per second or per minute. There is a table in the OpenTelemetry Collector repo trying to give you a bit of a sizing idea, how much a request each container is going to ingest. That is very, that may vary depending on your configuration, but it's going to give you some clue on how much resources you need to put to manage your load. As I said earlier, but let me give you a bit more tips and drill down into that. The monitoring part is critical. The OpenTelemetry Collector is getting a ton of data, and it will going to lose some of it. Unless you have tons of experience with it, you are going to make some problems. So I'll start with the simple stuff regarding logs. Never run in production log level debug. I know it may sound like, yeah, that's obvious. I saw that in production too many times. And what the collector is doing in debug mode, it's writing every single request it's getting to the log, and that's getting way too much. So don't do that. But please do send the warning and the alerts, the warning and the errors to your main logging solution, and also have alerts on that, because you may get errors in your collector and you may not notice it, and you just miss that. So that in terms of logs, in terms of metrics. So the OpenTelemetry Collector can export Prometheus metrics, how many times that it failed to export, failed to accept data. It manages all kind of queues, and they're getting full, and then you're starting to lose data. So exports it to Prometheus, set some alerts on that as well. So you will be on top of things when they are failing. All of that is managed for you in the chart itself. Simple configuration that you can define. You're just defining the Prometheus server you want to send, and it's working for you. Okay, so now after all of that, we have the OpenTelemetry Collector running in production or on Kubernetes environment, and everything is running great. Now we need to really send some data to it. We really going to send some telemetry data to it. So you have two options here. The first one is just have your application instrumented with OpenTelemetry. This means that the developers in your application, in your system, your team, your R&D, had to go through each individual application and instrument it, import the library, initialize it, and play with the configuration. That is actually, I guess, most company would do. It's very kind of the straight way to implement stuff, but and there is some benefit to it, but there is another way. That is to use the OpenTelemetry operator, the Kubernetes operator, and that is allowing us to actually inject the OpenTelemetry SDK to the application without making code changes. So first of all, a disclaimer, it supports only .NET, Java, Node.js, and Python. If you're using anything else, currently there isn't support. Maybe there will be down the road. And it's actually giving you two options. Either you are doing all the different configuration of the OpenTelemetry SDK using environment variables, a common ones that the OpenTelemetry supports. And the other one, you can even create your own custom image that initialize the OpenTelemetry SDK. Again, I wouldn't do that unless I have to. The environment variables are very easy to configure, so I would go with that. The configuration looks as follows. So here you can see the OpenTelemetry operator and how it's being used in the chart. So you can see here we have metadata, we've got the name. We are exporting the data to the OpenTelemetry Collector, providing the endpoint here. Here we're attaching some context propagation mechanism, and we are doing sampling, that is parent-based sampling in 25%. So that is allowing us to do all kinds of configuration, and that works great out of the box. If you're interested in looking how it really works, you can go to the repo, and in the chart repo, you have the OpenTelemetry demo, and here you can see how to actually configure the operator and make it work. So let's talk about, I think, the last part of this talk. OpenTelemetry, especially spans, are super expensive. Metrics is something that is cheaper because we're talking about numeric values that you need to store in a time series. That's not an expensive data store. Logs is a bit more expensive. We're talking about text that you need to store, usually in Elastic. That's getting more expensive, but you control the amount of logs that you generate, right? If you have something that's too verbose, you can change the severity, the log verbosity, or you can comment it out. Talking about distributed tracing and spans, because you're doing this auto instrumentation, because you just initialize the operator auto instrumentation, now you have this SDK that's just shooting out spans, and it's just getting too much expensive. So what would OpenTelemetry would tell you? Tell you, hey, you can do sampling. So sampling means let's take a percentage out of the data. So let's not take 100% of the traces, let's take the 10%, that would reduce the cost. So you have two options that. One is called head sampling. This is made in the SDK itself. When we are creating the first span of the trace, we need to decide whether we want to keep it or not. And it's working, however, it's pretty limited because we have very little visibility into the entire trace. We have visibility only to the first span as it's created. I don't know how long the trace looked. I don't know whether it was successful or failed. So it is very efficient if you just want clear cut of 10%, but it doesn't give you the ability to take decision on the entire trace. Then you have the second option. The second option is tail sampling. Tail sampling means that you get 100% of the traffic to the collector. The collector would accumulate all the different spends within the trace and then take a decision on the entire trace. And this is giving you a lot of power because you're looking at all the traffic, you're looking at the entire trace, and you can say anything that you want, any rule, you can apply any rule that you want on deciding that whether you want to sample it or not. You can check if it has errors, you can check that if it's a specific API call and it's 500, you can check that if the latency is too high, that's giving you much more power. With great power comes great responsibility, which means that it's how to operate in production. Why? Let's see. So in order to take a decision on the entire trace, we first need to aggregate it. We need to make sure that in a single container we have all the spans. We have all the spans that relates to the same trace ID. So when an SDK is sending out a span, it's sending it to a random collector. Let's say you have 3 OpenTelemetry collectors, and some part of the trace would end up in pod number 1, and some part of the trace would end up to pod number 2, and now you can take a decision on the entire trace. The way that it works is we have 3 layers, right? The OpenTelemetry SDK is communicating with some load balancer, let's say a Kubernetes load balancer. And then it sends it out to the first layer of OpenTelemetry Collector that it's only a trace ID aware load balancer. What that means? It means that this, this OpenTelemetry Collector is getting a span, and it has 2 data points. The first, it knows how much OpenTelemetry Collector it has to send to. And also, because it knows that exact number, it can run a hash on the trace ID and determine to which collector it should be sent. Meaning that the same trace ID would be sent to the right collector because it has the same trace ID. So spans of trace ID 1 that will end up in the first and the second load balancer would eventually end up in the OpenTelemetry or the right pod. That is allowing the pod to get all the relevant spans to that trace ID, accumulate it for a defined time, let's say, I don't know, 50 seconds. Now we waited 50 seconds, we are looking at the trace, and then we're taking a decision. So this is tail sampling. This is again showing you the power of the collector, but also the complexity, right? We started with let's spin up an OpenTelemetry collector and have some replicas. Here we're starting to see that it's a bit more complex to run. The OpenTelemetry Helm chart doesn't support it. This is why Aspecto released its own chart. So our chart, we did that specifically to have support for the tail collector. So if you're interested in running the tail collector and you're not looking to manage it yourself, you can look at our chart and use that. So this is how to kind of manage the load and still be cost effective. So if we are, you have some questions, Eran, you want to ask?
Yeah, maybe we'll leave it to the end. We're already past time. So yeah, I'll let you wrap it up.
Cool. So now we understand OpenTelemetry. We know how it works. We understand this entire stack and all the different components. Always keep in mind, this is a big data pipeline running tons of data. So always remember to run your metrics and logs. And just before you're going to production, if you're interested, we actually have our Bootcamp episode 3 and 4. That's probably what you want to do. And looking at the Bootcamp is a episode, 6-hour course, free, vendor neutral, not related to Aspecto, that you can go and learn with more details about OpenTelemetry. And if you have any questions, I would love to hear them.
Bearing with us. I know we are a little bit late. There are a few questions. We'll try to maybe answer 1, 2 of those, and the others like to send some materials that are relevant. We also we'll publish a link in a second to our Slack channel within the CNCF Slack, the OpenTelemetry Bootcamp, where you can follow up with questions over there. I think one big question, Michael, that we heard was regarding correlating the different data streams. If I'm currently using like a traditional vendor like Datadog or someone else, they have their agent, and in their platform, I can see everything together. But when moving to OpenTelemetry, I might be using, Jaeger to see my traces, and X-Ray for something else, or vendors like Aspecto. So what are the ways to actually see logs and traces together nowadays? Obviously, it depends on the vendor, but as much as you can share.
Yeah, of course. So if you're talking about open source, each open source is usually looking at a single telemetry. So you wouldn't find a good solution out there in the open source area. If you're talking about vendors, most vendors supports this correlation. I know at Aspecto we support it, and different vendors have different level of ability to correlate. So it's kind of up to you to check it out. I'm a bit biased because I would say that Aspecto is the best one, but that's I'm not the guy to ask that.
Also, we've touched that the fact that we can use different communications like gRPC and HTTP. What are the trade-offs over there? Why should I use each one, or why should I use both of them?
So in general, you would probably choose the gRPC one. It's more efficient, it's more performant. In some cases, you may have to use the HTTP one. If you're talking about browser instrumentation, specific languages that doesn't have gRPC support. I know AWS Lambda function had few issues with that, so you just may need to use the HTTP one.
Okay, cool. We had some other few small things, but maybe we will address it like in our channels, because we are already past time. So I see that folks are already starting to leave. You have to go to sleep at some places around the globe. So thank you everyone for joining us today. Feel free to reach out in the different medias, like over the Slack. Just reach out to us on LinkedIn, Twitter, whatever. Happy to answer questions and help you with your OpenTelemetry journey. We'll close the poll in a second, and we'll publish over social media as well, like the results for you to see. So thank you, everyone, and thank you, Michael, for this amazing session.